Okay, I'm gonna solve some problems of 5, including problem 9, and solve some of the other ones using unit analysis, not the flow chart. And what we're gonna do here, okay, here's it. What we're gonna do here is perform the following conversion, making use of unit analysis. So here we go from number of molecule. Let me stop and put a pause here to see which problem it is from the homework. Okay, I'm solving problem number 6. Problem number 6. Okay, and here it says perform number 6. And it says perform the following using unit analysis. I'm going to use unit analysis so you can see how do we solve it in a different way. Basically, that's what we require. If you can use the flow charts, that would be good too. So we got letter B. This is 6B. And it says number of molecules of NH3, of the molecules of NH3, okay, with 15 hydrogen atoms. Now, if you look, there's no need to use Avogadro's number. Why? Because you're going from atoms to molecules. Okay, that's it. So, number of atoms to number of molecules. So, if you got here in NH3, they're asking for the number of molecules of NH3. So, the number of molecules, I'm going to put it here, of Na3 because Na3 is a compound. So you use molecule is 15 hydrogen atoms. Okay, how many hydrogen atom you got on one molecule of NH3? You got 3 on one molecule of Na3. You got equal 3 hydrogen atoms. So this is our conversion. We multiply by our conversion, the unit analysis. So is one molecule of NH3, right? Because that's what we want to get. Divided by 3 hydrogen atoms. So if you divide this, you cancel out the units and you divide 15 over 3, the number of molecules of Na3 is equal to 5 molecules. And this is the same as I said of NH3. This is the same as I said that when you're converting from molecules to atoms, you multiply by the subscript from atoms to molecules because that's what they're asking for. You divide by the subscript. The subscript is 3, 15 divided by 3 is 5. So that's the same thing. Let's go ahead and solve the next one. Okay, here you got grams to number of carbon atoms. Here you got, if you go through the flow chart, you first convert it to moles and then you convert it to carbon. So the first thing is, in 1 mole, right, of C3H7, right, O8, you got how many grams? You have to calculate the molar mass. Let me get a calculator here. And I do it directly. Okay, for here, 3 carbon atoms, right? It's 3 by 12.011 plus 7 plus 1.0079. And this is, of course, grams per mole. Per mole. If you look at here, right? Periodic table. Oxygen is 15.9994. 1.0079. Okay, so, and by the way, you got 7 hydrogen plus 1 here. You add them, right? So it's going to be 8 hydrogen in total. Plus oxygen, you got 1 by 15.9994 grams per mole, or grams in 1 mole. And this is going to be 3. Now I'm going to put a pause, right? While I do this calculation so we don't waste time on the video. Just Okay, I did it. I don't know if you did it. You can verify the calculation, but it's 60.0956. We leave it with the same amount of sig figs until we finish the problem. So you got that 1 mole of a compound, okay, of this whole compound. And by the way, this is propanol. Um, and it's going to give you 1 mole is going to be 60.0956 grams. Or grams per mole, but 1 mole. So you got the first thing you have to do is convert it to moles and then to carbon atoms. And to do this, you got, okay, 33. Let me do it on the bottom because it's going to be a little bit long. So it's going to be 33, right? 33.4 grams. Now we want to take it to conversion factor would be, you want to take it to mole, 1 mole divided by 60.0956 grams. Cancel out grams. And then we continue, okay? We continue to number of carbon atoms. So what do you need to do? You first need to determine the number of molecules of propanol, sorry, molecules of propanol by multiplying by Avogadro's number, because Avogadro's is 6.02 by 10 or 223 by 10 to the 23rd, and it's going to be, in this case, it's molecules per mole. So we multiply by Avogadro's number to obtain the number of molecules of propanol. Doesn't matter if I put the 2 or no. You're going to use the one I gave you in the test. I'm going to give you all those constant. You don't need to memorize them. 23, and this would be number of molecules divided per mole. Now we cancel out moles, and we keep on going because we still need to find out the number of carbon atoms. How many carbons do you have here? 3 carbons per molecule. So 1 molecule of propanol, OH, is gonna give you, is gonna be equal, you're gonna have, sorry, 3 carbon atoms. So to use unit analysis, we need to obtain atoms on top, okay? So we got 3 carbon atoms. In other words, we multiply by the subscript. The subscript of carbon is 3. And on the bottom is number of molecules of propanol. So molecules and molecules, this is molecule, cancel out. And it's going to be 33.4 multiplied by 6, multiplied by 3. Now I'm going to put it in pause also to do this calculation. If I made a mistake, I made a mistake, but do it by your own in the meantime. Okay, Yeah, I don't know if you got the same thing, but again, 6.03204 by 10 to the 25th carbon atom. But just now remember something. We got three sig figs given. Conversions doesn't matter. Molar mass doesn't matter on significant figures. But 33.4, yes, because that is our uncertainty. Okay, so on our sig fig. So we take it to 3, 1, 2, and 3. Remember, the exponentials don't count as significant. 6 point is only to tell you the decimal place, so it doesn't count. And it's going to be 6.03 carbon atoms. And this is the answer. Now the next one, okay, it's 8-point carbon atoms in C4H10 hydrogen atom. This is an interesting one because we either get the ratio between 4 and 10 before carbon and hydrogen, or we go to molecules of this is butane and then convert it to hydrogen. So we can do directly, I think so. If we need to find out the hydrogen atoms, and we have the carbon atoms, we go, okay, or 8.46 by 10. This is an 18, I think so. 18, yeah, carbon atoms. Now, how many hydrogen atoms you have? And we put it on top because that's what we want. 10 hydrogen atoms in, right? In 4 carbon atoms. This is the conversion. Carbon atoms. This is the conversion, meaning that in one butane C4H10 molecule, we have 4 carbon atoms and 1 hydrogen atom. Let's put it in a different way to see if you have a doubt here. Okay, meaning that in one butanol molecule, you have 4 carbon atoms. And at the same time, right, in one in one butanol molecule, you have 10 hydrogen atoms. So you equal both, right? And for carbon, you equal both molecules of ethanol in both sides. And this side, 4 carbon atoms, would be the same as writing this. Is equal in a molecule of butanol equal 10 hydrogen atoms. So if you use the conversion, we want to get hydrogen atoms, so it would be on top and on bottom the carbon atom. So you just have to do this calculation and again put it on pause and you're going to do it yourself. And this is going to be 2.115 by 10 to the 19 carbon atoms and carbon atoms cancel out, and it's going to be hydrogen atoms. So sig figs would be 1, 2, and 3, right? If you look at the problem, 1, 2, and 3, so it would be 1, 2, and 3. So it would be 2.1. You have an odd number and a 5. It is 2.112 by 10 to the 19 hydrogen atoms. Again, let me explain. I don't know if you remember. If you got a 1.5, if it's even and a 5 here, you round it to 2. If it's odd, sorry. And every time you had an odd number, you round it up. Every time you have an even number, you leave it the same. It stays the same. And this is going to be 2, 2. Okay? Just to refresh some of the things let me, if you want to go back to copy this, but this is basically it. Okay, so let's go ahead and solve the last three, part A and B. Problem 9. Okay, and we go here. Calculate the molar volume. What does it mean, the molar volume? Molar volume, and it's underlined, and it's the volume of 1 mole. That's it. Volume of 1 mole of sodium metal. It gives you the element, right? And it gives you the density. The density of the sodium metal is equal to 0 of 1 mole, 971 grams per milliliter. This is the density of sodium metal. But you know, right, that to find out the volume, density is equal to mass over volume, or your little triangle here, right? Mass on top, density, and volume. So if you want to find out the volume, it is mass over density. Can you find out that? Because that's what they're asking for. The problem is asking for that. Okay? And if they're giving you the density, they're telling you, in other words, use the density formula. Okay? So you need to find the volume occupied by 1 mole. It says it here. Okay? Now, what is the volume occupied for 1 mole? And can you find the mass? Yes, because we know by the concept of molar mass that 1 mole of sodium weighs the molar mass of sodium, which is going to be 22.98977. So it's going to be 22.98 977 grams. So if that's the mass for 1 mole, the only thing you have to do is plug in the value. The mass for 1 mole is 22.98977 grams divided by the density. What's the density given of sodium metal? Is going to be 0.971 grams over milliliter. Or divided, yeah, by 0.9, no, I forgot the number, 971 grams over milliliter. Grams with grams canceled out, and it's going to be 22.98977 divided by 0.971, and the volume, the molar volume of sodium metal, right, is going to be 23.6763817 milliliters. Now, hold on. How many sig figs do we have to put? Molar mass, no sig figs. The only thing we have to consider is the sig figs they gave us in the problem, the data given, which was a density with 3 sig figs. So our problem should be that the volume of sodium metal, right, is going to be 1, 2, and 3, right? We drop all this, and it's going to be 23.7 milliliter. And that's the answer for this. And let's keep on 9B. This is problem 9, letter B. And this would be the liquid CH3 Br, right? And this would be Br3, tribrom tribromine methane. And it's CH, by the way, Br, basically it's the skeleton with the lone pairs. Okay, has a density of 2.89. This is very similar to the letter A. The only difference, instead of being the 1 mole, the, the they're asking for the volume of this amount of molecule in which the number of mole changes. Okay, and instead of sodium metal you have to use this smaller mass. So let's go ahead and again, volume is equal, they're asking for volume, so volume will be equal to the mass over the density. We got the density, now the mass, this is what they're asking for, and that's the why I use this equation. So, but what is the mass? Can we find out the mass? Yes, because given the number of molecule, if we go ahead and do this following conversions, okay, you get here, to get the mass, okay, of the liquid CHBr3, we go ahead and use the number of molecules that we have of the whole compound. Then we do the conversions, molecules, with Avogadro's number, right? By what? Divided by Avogadro, because this Avogadro's in 1 mole of compound of a compound of a molecule, you got 6.02 by 10 to the 23rd molecules. You see, this is how we molecules, how we cancel out. Now, we're gonna have moles, but we still have to convert it to mass and to use, and never forget, for the conversion of mass to moles, or mole to mass, this is mass, and this would be moles. You use always the molar mass, mm. So what we need to do here is calculate the molar mass of CHBr3. So its carbon would be 1 by 12.011 grams per mole, because it's the grams in 1 mole, plus hydrogen 1 by 1.0079. And I think bromine is 79 something, but I want to make sure. You have 3 of them, and it's gonna be, I have it here, the bromine 79.904. Yep, 79.904. And this is grams per 1 mole, grams per 1 mole, and grams per 1 mole. Okay, now we're going to do the same thing. I'm going to pause it and you're going to calculate it yourself to see if you got the same as me. Okay, so I didn't check it out. If you got the same as me, perfect. If you didn't, that's double check your calculation of mine. If you're sure you got it right, use your numbers. But basically, you know that 1 mole of CHBr3 is equal to 252. Do not touch the stick fix yet. Just the ones from the periodic table, use them all. Grams. So let's do the conversion, because if we want grams, right, to use it, why do we want grams? Because we want to use it on the density formula. And it's 252.7309 grams per 1 mole. So moles and moles cancel out. So now we got everything in grams. Again, another calculation, but I'm going to do it real quick right away. I do it like that, having you do it and I pause the video so we don't waste time on the video. This would be 23 and 24 cancels out and you have left 1 here. So it's 334.0, right? Multiply by 252.7309. And that is giving you, well, I'm going to have to check it out because it's a big number. And it's going to give you 88,592.8506. Leave it like that, grams. So it's going to be 8.592. You can still round it here because we're going to have to, if the density is given in 3, the sig figs is the same. But let's leave it like that. 0.6 by 10 to the third, right? 1, 2, 3. So let me do it again on the calculator, okay? And just double check your values too and pause the video. I got the same results. So this is going to be the value for the mass. So what would be the volume? Okay, we know that the density given here is 2.89 grams over milliliter. So the density, the volume would be equal to the mass, 8.5928506 by 10 to the third grams divided by, okay, 289 grams over milliliter. 2.89 grams and milliliter goes on top because it's on the bottom, grams over milliliter. And that is going to give me, right, 8.5928506. And this is equal to 297. I took it to 3 fixed, right? Okay, so it's 2.97 already 3 sig figs because remember the density is given in 3 sig figs by 10 to the third milliliters. Here you go, and this is the answer for letter B. Let me double check how many minutes I have here. Let me see if I can do the last one. The last one is a little bit tougher. I know some of you would try. This is a lot tough. Um, if you try on the homework, it's okay. If not, I wouldn't worry about it. I'm not gonna put something like this because it's basically the bromine. It has a combination of the isotopes. So it's gonna be 81. I'm gonna put an announcement. 75.0 milliliters of liquid bromine, Br2, and the density is gonna be 3.12 grams over milliliter. Okay, so a natural abundance of 89 of 81, right, is 49.46%. Okay, and this is the bromine 81. Now, they're giving you the milliliters, they're giving you the density, and what they're asking is for the number of atoms. So you go in the opposite way. You have to find out the mass, which is the density by the volume. Let's start with steps. From the mass, then you're going to have to find out the atoms. How? The mass, you convert it to moles, and then you convert it to atoms. But we have a problem here that the mass of 81, right, is not the whole molar mass of the compound. Why? Because you only got a 49.46% of the 81. When you look at the periodic table is giving you the 79.904, which is the isotope average mass. So what you had to do? Okay, do you remember that the isotope average mass is going to be the fraction or the percentage, the fraction of one multiplied by the atomic weight, sorry, of the isotope 1 plus the fraction of the second one, 0.4946 multiply by the atomic weight of the second isotope. So this is what you need to find out to convert mass to mole because you don't have you only they're only asking you for 81. Okay? So you got here that the average that the fraction the average is 79.904 and that the 81 is a 0.490%, 6% of this, and that's how you do it. But let's do something with this problem because it's a nightmare for you. Let's just consider that the 81 is all of the bromine. So let's assume that this is the bromine 2. And by the way, 2 means the molar mass. I'll tell you, in 75.0 milliliters, the volume they're giving you, what I did is the following, okay? In the problem, they're asking you to calculate the the number of atoms of bromine 81. You know what I'm going to do to simplify this problem and for you guys, if you're having trouble or you had trouble with this, just let's do something. Forget about the 81. And what they're asking is, okay, what is the number of atoms in a bromine atom? Okay? Bromine. But what do you have to do? They're giving you the density, right? So I'm sorry here for the two. It's not a molecule, the atomic. It's something normally it's the atomic molecule, but they're asking for the number of atoms of bromine. That's what they're asking. Br number of atom. So again, volume, they're giving you the volume and they're saying that is 75.0 milliliters. And that the density, okay, and look what they're doing of Br2. And the density of Br2 liquid is 3.12. Okay? Forget about the natural abundance. I explained it to you how you should do it, but it's too tough, honestly. And right now, at this point, we don't want that, and you don't need it either. We don't want to combine one thing with another. This was part of the last exam. Okay, if you're interested in this, I have no problem to get into it and solve it. But I already told you how you solve it. You want to try by yourself? Perfect. I do not recommend you to do it before the test tomorrow. So volume of Br2, look at the difference, okay? They're asking for the Br atoms. They're giving you 75.0, right? And they're giving you the density of 3.12. So the density of Br2 would be 3.12 liquid grams over milliliter. So what do you think is going to be the first thing? The first thing is to find the mass. How I said, and from the mass you go to the number of atoms. But, okay, let's go ahead and start here. You got the mass would be equal, like we did in the problem the prior, density by volume. And it's going to be 75.0 milliliters multiplied by 3.12 grams over milliliters. You cancel out milliliters and it's going to give you 234 grams. 3 sig figs, no problem. Of BR2. Remember, they're giving you the data of BR2. Now, but they're asking for the bromine atoms. How many atoms of bromine you have on a molecule of BR2? You have 2. So what do you have to do? First of all, they're asking for the number of atoms. How do you calculate the number of atoms of Br? Okay. You do first the conversion between grams to moles first, grams by how? Divided by the molar mass. But first you have to divide it because remember this is the mass of Br2. So you first have to find out the moles of Br2 and then let me write it down. The moles, you first have to find out the moles of Br2 by dividing by the molar mass, right? Mm, 1 over the molar mass of Br2. Then you have to go ahead and find the number of molecules of Br2 because Br2 is a diatomic molecule, right? by dividing by Avogadro's number 62 by 10 to the 23rd. Then you have to find out the number of atoms. By how? By divided of BR, because that's what they're asking. Okay, don't get lost. And then dividing it by the subscript. Okay, the conversion. So let's go ahead and finish the problem. You have 234, right? And let's do it here. 234. So now what you had to do, in 1 mole of BR2, you have how many grams? It's gonna be twice, because that's the molar mass if you look at your periodic table, by 79.904, okay, grams in 1 mole. So it's gonna be 79.904 by 2 equals 159.808 grams per mole. Okay, it's in 1 mole. So what do you have to do? You 1 mole, so 1 mole on top, and then you divide it by the molar mass, which is 159. Remember, molar mass, do not round it. Just leave them all the sig figs. And this would be grams. So grams and grams cancel out. So now you're going from moles to number of molecules of Br2. And remember, we still need to get 2 atoms. So what do? Okay, again, the Avogadros, and you divide. And it's going to be 1 molecule of Br2, because that's the conversion between moles of Br2 and molecules. Contains 6 point. I did something wrong. I know, I was thinking, and before I continue, I found out. Because the conversion is, okay, you got 1 mole is equal to 6.02 by 10 to the 23rd molecules of Br2. Br2, we're still with the atomic molecule. So we are going to go ahead and multiply by Avogadro's. Here is wrong. So we have to multiply by Avogadro's 6.02 by 10 to the 23rd molecules of Br2. We're still with Br2. Okay? And 1 mole. So again, we cancel out moles with moles, and we go now to convert this to atoms of bromine. Now, let me erase the top one for a second because it's going to become a mess. The conversion would be then that in 1 atom, in 1 molecule of bromine 2, of the atomic bromine, 1 molecule of Br2, how many atoms of bromine you have? 2 atoms of bromine. So now you go ahead and multiply by 2, because in 1 molecule of Br2, right, you got 2 Br atoms. So here would be 1 molecule of Br2. So this and this cancels out, and you multiply everything now. And I don't know where do we start? Okay, I'm going to pause again. Okay, see if you got the same. I got 282, already 3 sig figs. Remember, our data was given in 3 sig figs, which was the density and the volume. 3 point, the density 75, the volume 75.0, and the density 3.12. So we keep the 3 sigs, the 3 significant figures, and we're gonna get here the 282 by 10 to the 26 atoms of Br. Do it. If you don't have it identical, just let me know. Send me an email. But I think it's right. Okay? And that's it for now. Next thing, I'm going to solve the Lewis structure of homework 4 and the quizzes.